Hello everyone, in this video we are going to discuss what is alpha hydrogen as well as alpha carbon. So in previous video we saw a Cannizzaro reaction. In that Cannizzaro reaction I just recall what we saw in previous video. In Cannizzaro reaction the substrate which we use is aldehyde, especially the compound which does not contain alpha hydrogen. So in this video I will explain what is alpha hydrogen. So before we are going to see what is alpha hydrogen, I will make you know what is alpha carbon. So first, what is alpha carbon? The carbon which is present next to any functional group is known as alpha carbon. Remember, the carbon which is present next to any functional group is known as alpha carbon. So coming to the example, this is acetaldehyde. In this acetaldehyde, what is the functional group? The main thing is, first you have to identify what is the functional group. So here CHO, this is the functional group. So according to the definition, the carbon which is present next to any functional group. So in this first example acetaldehyde, CHO is a functional group. So the carbon which is present next to the functional group is this carbon. So please make note of it. Don't consider this as a alpha carbon. So this is a functional group carbon. This is not an alpha carbon. The carbon which is present next to the functional group is alpha carbon. So in this compound, this carbon is alpha carbon. Right. So here for this second compound, first step is, what is the steps to identify alpha carbon? First you have to identify the functional group. Here this CHO is a functional group, so the carbon which is present next to this functional group is this one. So here this carbon is a alpha carbon, right. So here how many alpha carbon is there? So first step, what is the first step? You have to identify the functional group here. So this is keto compound in which CO is a functional group. CO is a ketonic functional group. So if you see, this CO is a functional group. Either of the side there is a attachment of carbon. If you see this compound, this ketone to this ketone, either of the side two carbon is directly attached with the ketonic functional group. So therefore these both the two carbons which is present at the terminal will be considered as the alpha carbon, right. The carbon which is directly attached with the functional group is alpha carbon. In first two cases, in these cases only this carbon is directly attached to this functional group. Here only this carbon is directly attached to this functional group. But here, being the middle of the compound, this ketone is directly connected to two carbon. Therefore both these carbons will be called as a alpha carbon, right. So in this first structure only one alpha carbon is present. In this structure only one alpha carbon is present. Here two alpha carbons are present, right. So coming to alpha hydrogen. So what is alpha hydrogen? The hydrogen which is directly attached to alpha carbon is termed as alpha hydrogen, right. So the hydrogen which is directly attached to the alpha carbon is termed as alpha hydrogen. So if you see here, so to find out the alpha hydrogen, first we have to find out the alpha carbon. So as I said earlier, in first structure this is alpha carbon. How to identify alpha carbon? To the functional group, the carbon which is directly attached to the functional group is alpha carbon. See, don't mistake this functional group carbon as alpha carbon. No, it is not, right. So the carbon which is directly attached to the so the carbon which is directly attached to the functional group is termed as alpha carbon. So here in first structure this is alpha carbon. So the alpha carbon is directly attached to these three hydrogen. Therefore these three hydrogens are termed as alpha hydrogens, So coming to the definition, the hydrogen which is directly attached to the alpha carbon is termed as alpha hydrogen. Therefore, this is an alpha carbon. To this 3 hydrogen is attached, which means there are 3 alpha hydrogens in its structure. Coming to the second compound, so this is alpha carbon. To this 2 hydrogen is directly attached to this alpha carbon. Therefore, 2 alpha hydrogens are present, right? So coming to this compound, we know either of the carbon is directly attached to this functional group. So both these carbons which is present in the terminal are alpha carbon. Therefore, this is also alpha carbon, this is also alpha carbon. So this alpha carbon contains 3 hydrogens, which is also known as 3 alpha hydrogens. This alpha carbon also contains hydrogens. So total 3 plus 3, total 6 alpha hydrogen. See, irrespective of the carbons and hydrogens, all the hydrogens which is directly attached to the alpha carbon is termed as alpha hydrogens, right? So coming to the aromatic compounds, benzaldehyde. As I said earlier in our previous video, we discussed about the alpha hydrogens, right? So in Cannizzaro reaction, we should take the aldehyde which does not contain alpha hydrogen. So benzaldehyde does not contain alpha hydrogen. How? If you see, so this CHO is aldehyde functional group. First you have to find out the alpha carbon. So this CHO is directly attached to this carbon, which I pinpoint with the blue ink, right? If you see here, this blue color ink, this represents alpha carbon. This carbon is directly attached to the CHO group. So this is alpha carbon. If you see this alpha carbon, it already has 4 bonds. See, 1, 2, down 2 double bonds are there, right? 1 double bond is there. So 1, 2, 3, 4. So 4 bonds are satisfied for this carbon. Therefore, there is no hydrogen left out for this carbon. We are having alpha carbon for this compound, but there is no hydrogen is directly attached to this alpha carbon. So therefore, there is no alpha hydrogen in this compound, right? So this compound does not contain any alpha hydrogen. Therefore, this compound is suitable for Cannizzaro reaction, right? The same for formaldehyde. If you take formaldehyde, the formaldehyde also does not contain any alpha hydrogen. So we can use both formaldehyde and benzaldehyde for Cannizzaro reaction. Thank you.